For Sybil Hunter, our first step here is to launch a terminal and git clone the project repo. So it'll look like this: git clone, and I already did it here, so I won't run this command. Next step is to open the. I just have it saved on my desktop, but save wherever you want. Next step is to open the Sybil Hunter dashboard. So we're going to go to within our project directory. We're just going to click on this extension here, so the Xcode project. Oh, you make sure you have Xcode installed too. They believe this is version 14.2, so that might take a while to install as well. All right, so once we have our project up in Xcode, we're just gonna first check. So we're gonna go to signing capability within the Sybil Hunter project, and we're just gonna double check to make sure that sandbox is disabled. Now, what that will look like is this. So right here will look like something like this. You just want to delete it because that will allow us to run our sub processes outside of a sandbox. So our app is free range. Okay, so next step is to just build. Okay, so now we got our project up and running. Our next step is to create a pipeline. So what we're first going to do is import some addresses. Now, currently we only support it only supports TXT files containing Ethereum addresses. And let me just show you what these look like real quick. So within data source example, we have a couple in here. So I'll click on this random one. You can see what it looks like. So here it is, just regular Ethereum addresses separated by a return. So that's how it currently works. So let's import those. So that was in our project directory. So we'll do Legos. I believe it's just the main one. Yeah, so data source example, and then we'll just import that whole directory, whole folder. So now here they are. And we can drag these in, and as you can see, it will create, it'll import all the addresses and have a set score of 0, as well as the round, right? The I guess it isn't the round, it's just the name of the file itself. And we can drag in more, we can drag in more addresses or more files, and that'll create more of these subcharts. Let's see, here are all the addresses, quite a bit. Let's drag in some Legos. So we'll go to Legos structure, package Legos, and then we'll just import this folder again. Now let's drag in the Legos we want to use. I'll just use all of them. So let's just drag them all in. And they're set with a random color. Okay, so here they are. Now, you can also change the path of the Lego as well. So if you want to change how the script is run, you can, as well as with the command as well. So this will allow you to run not only Python scripts, but you can also run Node.js, C++, compiled C++, and so you can run whatever you want. All right. So down here we have the total amount of addresses Ethereum addresses, and the total number of sub-processes. Now, the way we get this number is just the amount of addresses times the amount of Legos we have. So 3 times 49, 147. Now, here we can also change the amount of sub-processes. I'm only going to run, we can do 3. I don't know. You have to be careful with this because it will crash due to memory allocation. So let's run this. Let me just make that a little smaller. So let's just press run. And you can see down here, we'll start to run. Oh, we're getting some errors. Okay, we're actually only going to run 2 processes. It did not like that. My computer was struggling with that one. Okay, so we'll let that run. Real quick, one thing to note is you might have to change the path directory, or the path to our ML models within each machine learning Lego. So within the association classifier and the behavior regressor, you'll have to change this to the full path. I believe it has to do with the way the script runs. I'm not entirely sure. But yeah, so just remember to change this to your path. Now, a good way to do it is just to, if you're using Visual Studio, it's just to right click and then just copy path copy path from our view models. Look like that. So another thing to I want to point out here is within each Lego, we have some settables. I like to call them settables. So our true blocks URL and the max records. Currently have set that to 10, so we're getting 10 transactions. Now, 10 transactions is not enough to really identify or profile an address, whether it's showing Sybil behavior, but due to time, I'm just gonna run 10 because it will totally kill your system if you run more than 10 on just for timing purposes. I'm just gonna run 10, but yeah, I would definitely increase that. I think a good amount is around between 70 and 100 transactions. You get a pretty decent profile. And that goes with k-means as well. So up top right here, we've got well, I'm running this 11 on this one, but they're all kind of relatively the same, which helps. All right, let's jump back over to our program, see where it's at. I don't think it's quite finished. Nope, it's still running. Let's pause it. I'm going to run some more processes real quick. Let's see if we can do 4. Well, I killed it again. Let's not change that. I just want to show off the final result here. So, starting from, let's do the bottom up because I think that makes more sense. We have our address that was used within each Lego, and each Lego is represented here by just the matching colors, the circles, and the score. Now, the score is just the result from each Lego. So if it produced non-Sybil behavior from that Lego, we'll get a 0. And if it produced, which is false, right? And then if it produced true, we'll add that to our score. So the higher the score, the more likely there is Sybil behavior. So yeah, and now we can see our file for each one. Now if we go to each file, this is the overview for each file. We can see the Sybil behavior. Now what this is showing is it's just the count of all the Sybil behavior and non-Sybil of each Lego. Now that's a little confusing because you'd probably think it goes off the score. Now I would do the score, but due to the amount that we are running, which is only 10 transactions per Lego here, or per address per Lego, our values here would be super off. It would just be 100% non-biased. So I just want to show off the Sybil and non-Sybil behavior within each chart without running an hour's worth of worth of data here. Now up top here we have our overview. So that's the combination of everything you see, Sybil, non-Sybil. The other thing is I wouldn't do just a score like this. I'd probably show another chart with green to red. So red being more Sybil, green being less Sybil. This is my first Mac OS app, so I had fun building it. It was definitely interesting. Thanks for listening.